The commands that we need to know when we work with EIGRP is, first thing is, if you don't see routes, then check at least the neighbors are there. If neighbors are there, then if route is not coming, maybe the neighbor is not advertised it proper. So knowing show commands is what actually helps you troubleshoot. People used to talk too much about troubleshooting, but no, there is no separate syllabus called troubleshooting. It's not a separate paper. Earlier there was a paper called CCNP T-shoot. Those were funny ideas. Actually, if you know a protocol well, you should be able to fix it. There is no need for a separate paper to teach how to troubleshoot EIGRP. So learning every topic in depth will help to troubleshoot easily. When I know BGP well, and when I have the topology in front of me, I know what I should see in the output. If it is missing, I will also know where I can go and check. So this is common sense. This is skill. This is skill. This is not certification. This is someone's general knowledge, skill. Troubleshooting is a skill. We need to have that skill. Whatever we learn from books, not sufficient. You need to put your interest to dig deep and understand where things have gone wrong, why I'm getting this incomplete output. So knowing protocol in depth will help to troubleshoot. And show commands are very important to see what is missing. One of the command is show EIGRP neighbor, which lists only the neighbors. Show IP route. EIGRP shows only the routes learned through EIGRP advertisements. And show IP protocol shows all the list of routing protocols that is enabled on the router. Not only this is for EIGRP, this is a command for all routing protocols. Show EIGRP interfaces helps us to check whether EIGRP is running on the intended interfaces. Show EIGRP protocol, sorry, show EIGRP topology shows what all paths available to reach destination. For example, to reach this destination, there is only one path via serial 0/0/1. In this output, there is no backup path for any destination. This output is taken from a router which is connected serially like this. There is no second path like this to reach this router. If you have second path, then you would have seen some alternate paths. Now, the other command is show IP EIGRP traffic that shows how many packet and what type of packet has been sent from this router as well as received by this router. All right. So let's move on to the next chapter. This configuring EIGRP advanced topic is going to give us knowledge on things like summarization, especially summarization, and then knowledge on enabling EIGRP to support unequal cost load balancing. As I said earlier, every routing protocol supports equal cost except BGP. Every other protocol follows metric. So when there is same metric on multiple paths, up to 4 paths by default, all protocol can do load sharing. BGP never follows metric. BGP don't use bandwidth or delay or any other silly things like MTU. BGP is policy based. So BGP will not do load sharing. There is no concept of equal cost because cost is not the metric of BGP. Policy is the metric of BGP. If policy matches, then path is determined. Now, BGP is not going to support equal cost multipathing or unequal cost multipathing because BGP don't care about any metrics like hop count or delay or bandwidth. Other protocols, all IGP protocols, all IGP, like RIP, EIGRP, OSPF, and ISIS. These four protocols are IGP protocols. They follow metrics like hop count, cost, bandwidth, delay, and so on. Sometimes fixed costs. Say, for example, ISIS. ISIS don't care about bandwidth or delay or anything. It is relying on fixed cost. Each link is 10. When I have 5 links, then cost is going to be 50 because each link is 10, fixed cost. It won't focus on bandwidth. Whatever, there is a cost in every protocol. RIP calls it as hop count, or EIGRP calls it as composite metric, OSPF and ISIS calls it as cost. Now, EIGRP supports unequal cost load balancing, which no protocols supports except EIGRP. No protocol supports feature called unequal cost load balancing. So this chapter is going to teach this valuable features that is there in EIGRP. Let's get into it. When we talk about summarization, we should understand that there are two types of summarization. One is the summarization that we do globally under EIGRP process. Under EIGRP process, in the older version, auto summarization is enabled. In the newer versions, disabled. That is what global summarization. There is also another summarization, route summarization, which is manual summarization. The previous one is automatic summarization. You just go and turn on globally, automatically the summarization will happen not just on one interface, on all interface before advertising. Only the summary route will be sent. For example, if I'll have another link from here. Now this 172.16.x.x, this may have 24, like x can be 1, 2, 3, 4/24. Now when I enable auto summarization, not only to this neighbor, it advertises the class full major summarized route. It is also going to send to this neighbor. Just one command, which is done under the router EIGRP, automatically summarizes and sends on every link, not just one link. And by default, automatic summarization is enabled on the older version. It will round it to the major network boundary. It means classful boundaries, major network boundaries. See, it is a classless protocol. Still, it is a classless protocol. But advertising a metric, by default, it advertises by summarizing it to, rounding it to classful boundaries. Advantages, when you summarize and send, you may have like 255 subnets in the third octet, 1, 2, 3, 4 up to 255. but how many you send is just one update. Summarization reduces the update size. Smaller the update, less the CPU and bandwidth utilized. On the receiving router, the CPU utilization will be less when you send only summary route instead of multiple detailed routes. Not only that, the bandwidth consumed on this link when you send the update will be less comparatively. Not only that, of the receiving router's routing table, when I send only the summary route, the routing table is going to be smaller. Okay, now what is manual summarization? Manual summarization is summarizing interface level. For example, this router B should get detailed subnets like 1, 2, 3. Detailed subnets. But only to this router beta, I want summary route. Then I cannot rely on this global summarization. I need to manually do this under this particular interface. Go globally, enable disable summarization globally if it is older version. If it is newer version, you don't need to do anything. By default, it is going to send detailed subnets in the newer version. All that I need to do is I need to go to that particular interface where you like to have summarized route to be advertised and enable manual summarization. I'm going to do this and show you, then we will proceed this. If the interface names are not visible here, click on this one. If you don't know, click this one. And you can also press this play button to turn on all at the same time. If your CPU is good enough to handle, but my laptop is a bit older one, so I'm going to start one by one so that the CPU will not get blocked. 52% just for one router, you see, that's why I don't on it at the same time. Once it is loaded, the CPU will go down. During loading time, CPU will be quite high. Okay, maybe I'll set idle PC now itself. As usual, I'm going to put network like 10.13.0.0/60. Usually I put the second octet by taking number from this router and this router. And the host portion will be .1 and .3 here. Likewise, between router 3 and 2, I'll put 23. Right, so I would like to have another loopback behind R1 and R2. Another loopback. Done. So because you are comfortable by using Notepad, I'm going to use Notepad now. Notepad, that makes our configuration faster and easier. Interface loopback 0 is this. Interface fast Ethernet 0. And let's enable EIGRP. Is it okay if I enable EIGRP here using Notepad? Is it okay? Yeah. Okay. So autonomous system 10 network is, and do I need to say no auto summary? Not needed. Why? Because it's newer version. This goes on router 1. Now let us verify the interfaces like the show IP EIGRP interfaces. This will show me the IP address that I have assigned, also the EIGRP running. This is the interfaces. These are the interfaces that runs EIGRP show IP EIGRP. I can say traffic or yeah. So far it has sent 6 hello packets, but nothing is received. But because you know the reason, we have not enabled EIGRP on the other end. And this is dynamically picked process IDs and yeah, this is packet data, blah, blah, whatever. This also like locally, internally it is for tracking EIGRP process. This is our number that we gave as a process number. Now on router 2, this is 2, and F00 is 23, and the last number is 2 here, and this is going to be 2. Nothing more. That's all I need to change. Put this on router 2. Okay. Now on router 3, we have 7 loopbacks. Loopback 1, 3.3.1.1. Loopback 2, 3.3.2.2. How many loopback interfaces we can create? As I said, as many as you like. No restriction. Millions you can create if needed. All right, on F00, it's 13.3. And the other interface is 01, 23, 3. Now, EIGRP, when I say 10, it runs on both F00 and F01. When I say 3, it runs on all this 7. So, selecting all, copy, put it on router 3. That's all. I'm expecting now 2 neighbors should come up. Okay, these are the 2 neighbors. Neighbor 102302, which is router 2. Neighbor 101301 is router 1. Show IP EIGRP neighbor will also show you. It first formed a neighbor with router 2, and then it formed a neighbor with router 1. When I see the route in routing table on router 1, I will see detailed routes, not the summarized one. Show IP route EIGRP. You see, By default, the newer version EIGRP never summarizes. It's a detailed one. Likewise, in R2, show IP route EIGRP. Oh, sorry, EIGRP. Even here, you see detailed routes. But let's say on router 2, I want summary route. On router 2, I want 3.3.0.0/16. This is how I want to learn on router 2. I don't want to have these subnets. The reason is the size of the routing table is big. You see, show IP route summary. If you put, it says that EIGRP is taking 1,672 bytes of memory. I want to reduce it. I don't want this much. I'm okay on router 1. On router 1, I'm okay with this memory consumption, but on router 2, I don't like this big number. I want to reduce it. How to reduce the size of the routing table? Summarization. Router 3, if it summarizes and sends, the impact will be seen on router 2. For that, I'm going to do manual summarization. Okay. So before I do manual summarization, I want you to make a note of something here. In the routing table of router 3, if you see show IP route, do you see any route pointing towards an interface called null 0? Okay. Now, what I'm going to do is I'm going to go under the interface which connects router to F0/1. This is the command. IP summary address for EIGRP 10 3.3.0.0 and 255. No wildcard mask. You just type the subnet mask. Okay. So we have told EIGRP, which is running on F01, to summarize like this. When it matches 3.3 in the first octet, ignore the other two octet and summarize like this. That's the meaning of this. Okay, after I summarize, I would like to show you the routing table again on router 3. On the same router, earlier when I was showing you, you only acknowledge saying there is no interface called null 0 here. But now if you see, there is an interface called null 0, and what network it is holding? The summarized network. You see, when you write a summary, that summary is having how many members? In our example, there are 7 members of the summary. So that summary root cannot point to a particular loopback. It cannot point to a particular interface. It's common for the summary is common for many interfaces. So it won't point toward a particular interface. It will point toward null interface. Null interface that avoids loop. If it point towards one particular loopback, then traffic will be jumping between loopbacks if it matches the first two octet. I repeat, in order to prevent loop, the summary route will be pointing towards null 0. That's the reason. So someone may ask question in the interviews like this, or you can also ask interview someone question like this. Why is that summary route point towards null 0? Answer is to prevent loop. If it point towards a single interface, it will cause loop. The reason is the summary route is part of multiple interfaces. It can be logical loopback interface, can also be multiple physical interface. Okay, after doing summarization, If you now go to router 2, okay, another reason why it is pointing towards null 0 is if the route is not seen in the routing table, it cannot be advertised. You want router 2 to, so you want router 3 to advertise to router 2 like this. You want router 3 to advertise like this, for which route should be available in the routing table. EIGRP cannot advertise something which is not there in the routing table. If EIGRP need to advertise 3.3.00/16, must be there as an entry in the routing table, pointing towards some interface. It's okay even if it is null in null 0. It should be there, only then it can advertise. Very basic rule. It is not only for summarization. I repeat, any protocol will advertise only the route that is there in the routing table. Okay, now let's go to router 1 and check. Router 1 will have by default those precise routes, no summary. And the size of the routing table is still the same. On router 1, still the same. Whereas on router 2, earlier the size was like this, but now it has gone to 540. It is because earlier we were having 9 routes, whereas now we got only 3 routes. We have summarized 7 into 1. Let's check the routing table now. You see, we got the summary. Simplified routing table. The size of the routing table is shrinked very small now. Now the router can be more efficient when the routing table is small. This is what we call it as manual summarization. Now let us go to router 3 and check another output. Show IP protocol. This shows that only on this interface summarization is done. 7 components are summarized. All right, 7 only for this interface. Other interfaces, it is disabled. Now, what will be the metric of summary route? You see, summarization is done for 7 interfaces. In our case, 7 interfaces are loopback interface. But in the real world, we will have physical interfaces, and not all physical interfaces will have same metric. Now, which metric will be given to the summary route? This may be another interview question. I repeat the question. Let us say this one is one interface, physical interface. This is another physical, another physical, another physical, another, all a physical interface of different bandwidth. And let's say the cost of this one is 12, the cost of this one is 15, the cost of this one is 8, the cost of this one is 19, the cost of this one is 13, the cost of this one is 2. What will be the cost of the summary route 3.3.0.0/16? What will be the cost of the summary route? It will be 2. You got it? Sorry? Yeah. The lowest metric of these networks, subnets. The lowest one is what? 2, no? The next lowest is 8. It will only take the lowest metric. Now, let's see whether it is there in the presentation. Should be there. Here you see summarization. The minimum metric of the specific route is used as the metric of summary route. Is it correct? Make sense? Yeah? Right. Now, What is manual summarization? Summarization is configurable on per interface basis in any router within a network. That is what manual summarization. Now, when a summarization is configured on an interface, the route immediately creates route, the summary route pointing towards null zero. This is to prevent loop. Now, when will the summary route be stopped advertising? Only when all the subnets, only when the last specific route of the summary goes down, the summary route will be deleted. Did you understand this point? When will the null interface get deleted? Only if all the loopbacks go down. Yeah, we have summarized 7 interfaces, right? Now, if one of the interface goes down, will the summary route go down? No. Only when the last specific route goes down, the summary will go away. Any question on this page? No, it won't go. It will not be removed. Mm. No, 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 no. That is not the meaning of this. The meaning of this is this is gone down, still the summary will be advertised. This has gone down, still the summary will be advertised. This has gone down, still the summary will be advertised. This has gone down, this is. Now, this is the last one which is remaining. Only when this goes down, this will disappear and this will stop going. That's the meaning. All right. Now, even though we have the summary route on router 2, we can still ping 3.3.7.7 because we got summary for 3. Right. So when you shut down, let me shut down on router 3, loopback 4. Interface loopback 4. I shut down. Now, when I shut down, no notification is sent to router 2. Router 2 will not know about that 4.4 going down because router 2 has got the summary. Notification will be sent to router 1. Earlier, router 1 was having this in the routing table, but now there is no route. So from router 1, if you ping, the packet won't go in first place. The packet won't try to go out because there is no route. But in router 2, the packet will go and router 3 will drop. Packet will go to router 3 and router 3 will drop. Router 2 will not even send. If I say trace route this, it won't even go first hop. See, it won't go. But if you go to router 2, let me paste the same thing to router 2. It first goes to router 3 and then it says no host. The host is unreachable. This exclamatory means host is unreachable. H means host, the final destination. So it goes and gets dropped on router 3. Whereas in router 1, it won't even leave the device. All right. Let's move on to the next topic in the presentation. So this is the global summarization. In the older version, we used to cancel summarization by saying no auto summary. In the newer version, you don't need to do that. It is by default turned off. And this is the manual summarization. You remember I gave under the physical interface. Optionally, you can also set some administrative distance. Not necessary if it is needed. If you have multiple routing protocol with different administrative distance, the protocol with lower administrative distance will be preferred, isn't it? Administrative distance, which is preferred, lower or higher? Lower. Hmm? EIGRP is 90, OSPF is hmm, 90. Yeah, yeah, that's what ah, yes, you see, that's what I just said, but I'm going to repeat again. You see, this is the router which is advertising the summary route, and this is where you configured this command. Okay, this is where you configured. Now, let's say you also have OSPF on this router. OSPF is also summarizing, EIGRP is also summarizing, and you wish to give preference to OSPF if OSPF exists. Let's say this is the condition. If OSPF exists, OSPF prescribed summary route to need to be considered. But administrative distance of OSPF is 110. EIGRP is 90. Now what you can do is to make EIGRP less priority, go and put administrative distance here 190 so that you can achieve the policy. As long as OSPF is available, EIGRP will not be effective. Though EIGRP is still there, it won't be effective. And when OSPF goes down, automatically this will be appearing in the routing table. Administrative distance is only when you have multiple routing protocol. Only when you have multiple routing protocol with same set of prefixes. Okay, next. Hmm, hmm, hmm. We used both global summarization as well as manual summarization. Yeah. Show IP route, I told you that will point towards null zero. Here they are advertising. Sorry, they are summarizing here. Uh, Here they are using global summarization. No, canceling global summarization. Here they are summarizing 170 to 16. Then 170 to 16 should point towards null zero. Let us check. Yeah, here it is. See, there are two null zeros, one for 10 network, another for 170 to 16. Each network will have different null zero interface because this is the summarization for all 10. You see 10.2 and 10.1. This is summary. And 170 to 16.1 and 170 to 16.2, this is the summary. So you should have two null zero. If you have third subnets, then three null zeros. Null zeros can be any number. Okay, we will talk about this unequal cost load balancing in our next class.